And let's just think about that here for a moment. I suppose, where was my mistake? My mistake probably was maybe here. Let me just think here for a moment. Actually, here's where it is here from this particular identity here. Okay. Uh, what we actually have here is this: is that from here. So we've actually shown something different here that we didn't actually require. We actually need this thing here. So I actually really want to bound this in here. Yeah. So you can actually see that if I bring the one across, it becomes, if I bring the one across here, this becomes, let's say that we have 1 plus x is less than or equal to e to the x, okay, which is less than or equal to 1 over 1 minus x, okay. Bring the 1 across, okay. Well, then what we end up with is x is less than or equal to e to the x minus 1, okay, which must be less than or equal to. So we're bringing the 1 across. We have a minus 1. So really what we need to do is we need to reduce this here by minus 1 as well, okay. So what we effectively have is 1 over 1 minus x minus 1. The common denominator is 1 minus x, which goes in once. And this goes in all over 1, goes in 1 minus x times. So it's minus 1 minus x, which effectively gives us, this is going to be x over 1 minus x when we distribute this minus 1 across here. And then we divide across by x, we end up with x divided by x is 1, must be less than or equal to e to the x minus 1 all over x, which must be less than or equal to dividing this by x. Well, the x is going to cancel, which now leaves us with 1 over 1 minus x. And now we get the limit. Whoops, that was a little bit of an error that I made there a moment ago. So now that what we actually have now is that 1 is less than or equal to e to the x minus 1 over x, which is less than or equal to 1 over 1 minus x. And now we get the limit of 1 as x tends to 0 must be less than the limit of e to the x minus 1 over x as x tends to 0, which must be less than the limit of 1 over 1 minus x as x tends to 0. Okay, and once again, the limit of a constant is just a constant. So this becomes 1 must be less than or equal to the limit of e to the x minus 1 over x as x tends to 0, which must be less than or equal to. And as x tends to 0 here, like what we had a moment ago, okay, this is just tending to 1. So once again, we have the sandwich term at play here. So therefore, we have the limit of e to the x minus 1 over x as x tends to 0 is equal to 1, which is exactly what we required. So a little bit of a boo-boo there, but hopefully you can actually see now that what we've actually ended up with, we've sort of shown two things here, is that the limit of e to the x as x tends to 0 is equal to 1. So that was actually interesting. That fell through here. But really what we wanted to show was, that the limit of e to the h minus 1 over h as h tends to 0 is equal to 1. So that's what we got. The reason why we wanted to show this here was, instead of using the Taylor expansion, okay, albeit the Taylor expansion actually is hidden away in our previous proof. So this whole thing actually just naturally tends to 1. So we can jump straight across here to this particular fact. But don't forget, the Taylor expansion is required here in relation to figuring out this particular identity. So it's quite similar, if that makes sense. Okay, guys, once again, this was Jonathan Lambert with Maths and Stats. And this video was another video in our series of videos dealing with calculus and differentiation from first principles. I hope that this video was intuitive, and more importantly, I do hope that was helpful for you. And thanks for watching. Okay, bye-bye.